When we discussed switches, we talked about the MAC address table. Well, it turns out that routers have a similar table called the route table. So let's look at our previous example, and for the sake of simplicity, let's name the router's interface as follows. We're going to have Ethernet 1, Ethernet 2, and Ethernet 3. So this router's routing table would look a little bit like this. This way, the router knows which interface to use depending on the destination address. So let's say that a packet has a destination address of 192.168.2.2, the router would know that it has to use Ethernet 2. If a packet, though, had a destination address of 192.168.1.4, then the router would know to use interface Ethernet 1. Now, the default route that we've discussed before is represented here by the IP of 0.0.0.0 with a matching mask of 0.0.0.0. And sometimes you'll see that written as /0. So this means that the interface Ethernet 3 is used when a destination IP is an IP that is not found with the other interfaces. For example, if we had a destination of 172.16.32.5, then the router would check its routing table. It would see that this IP address is not reachable either via Ethernet 1 or 2, and so it would forward it using Ethernet 3 as a default. And when we discussed layer 2 in switches, we took a close look at how MAC address tables are created in a switch. And with routing tables, it's a little bit different. So let's take a closer look at how those tables get created. And we can summarize the way that they get created in 3 different ways. Number 1, directly connected. Number 2, static routes. And number 3, dynamic routes. So let's talk about these for a little bit, starting with directly connected routes. These routes are the ones that are created in the router. So with our examples that we've used of 192.168.1.0/24 or .2.0 and /24, these are networks that are directly managed by the router, and so they're directly connected routes. But with static routes, these are manually added by the network administrator. So when your network has grown and you've got different network segments, a router needs to know how to reach a destination network that is not directly connected to it. So let's look at an example. Router 1 and router 2's routing table would look a little bit like this. Now bear in mind that each router vendor displays this information in different ways, but the same concepts apply. So what happens if a client is connected to router 2 with IP of 10.1.0.10, which uses router 2's Ethernet 1, and tries to connect to a server with IP of 10.0.2.10, which uses router 1's Ethernet 2? Well, router 2 looks in its routing table and it doesn't have a route to the 10.0.2.0/24 network, so the packet just gets dropped. Router 2 has no idea how to reach any of the networks that are connected to router 1 except for the 10.0.0.0/24 that is shared by both routers. Likewise, router 1 does not know how to reach the 10.1.0.0/24 network that is connected to router 2. So since we are the network administrators, we need to tell the routers how to reach those addresses. And for this, we'll use static routing. For this example, we will use the very popular IP route command. Again, the way that this is configured varies from vendor to vendor, and this is the Cisco way, but the concepts are the same. So the syntax for this command is IP route plus network to reach plus network mask plus the next hop. And the next hop is the IP that's used by the other router with a layer 2 connection to the device that we're configuring. So for router 2, we would use the following 2 commands. So let's look at the first line. IP route is our command. Then 10.0.1.0 is the IP that we want to reach that's directly connected to router 1. 255.255.255.0 is the network mask of the IP range, and then 10.0.0.1 is the next hop, which is router 1's interface connected to router 2's interface, sharing a broadcast domain. Now the same applies for the second line, but this time it's for 10.0.2.0. So now the client connected to router 2 can reach the server through router 2 and router 1, but there's still one more problem. Once the server replies to the client and the packet reaches router 1 will not know how to send the information back to that client. So we need to add a static route to router 1 as well. This is the same IP route command that we just saw, but this time we're adding a route for 10.1.0.0 at the same mask, and then at the next hop of 10.0.0.2. And so now all this means that our router's routing tables will look like this. And as you can see, we've added 3 static routes. As a neat exercise, you can actually also check the route table of your own computer and your network. For example, on Windows, we can run the command route print. The first one is my default route, and in simple terms, it means that any network destination and any mask use the gateway 192.168.0.1, which by the way is my next hop or my router's address, and the interface is my computer's interface IP, which in this case is 192.168.0.25. Now, if this wasn't already configured, like in our prior example where you are the system administrator, then you'd configure that default route using the same or similar IP route command. Also, if you're using Linux, you can do the same thing or check for the same thing using the command route or even IP route to get that information. And then on a Mac, you can use netstat-r. Now at this point, you might be a little bit confused because all of this is already set up for you in your home network and you've never had to run any of these commands. Now luckily, we don't have to because our home networks and devices usually learn all this information using what's called DHCP. So that's the third option that we had mentioned in this lesson, which uses dynamic routes, and that's a technique that we will talk about in the next section. So go ahead and complete this lesson and move on to the next.